Alright, so in this video, it's gonna differ from the last video just a little bit because in the last video, we had to write an equation and graph a line that was parallel to another line, but in this video, we're gonna have to graph and write the equation of a line that is perpendicular to another line. Okay, so first we have to ask ourselves, what does perpendicular mean? Well, perpendicular, I'm gonna try to draw. I'm not very great at drawing, especially online, but like this, if we have a line, let's just say that's straight right here, it would be perpendicular. Another line would be perpendicular to it. Okay, it doesn't have to necessarily go through the halfway point, but if that, again, that's a terrible line that I just drew, but they're perpendicular if those two lines meet at a right angle. Okay, I'm not sure why this line is so thick right now, but we're gonna decrease that. All right, so let me just try to redraw that again because that was a bad even for me kind of drawing. But two lines are perpendicular. Okay, that's a little better if they meet at 90 degrees at a right angle. All right, so these lines are close to perpendicular. Again, I'm not a perfect drawer, but they're perpendicular when they meet at right angles. Okay, so I'm gonna erase that too. So I'm gonna start with this one that says graph and write an equation of a line that is perpendicular to the equation y equals 4x minus 3 and goes through the point -1, 2. So there's two things in there. It has to be perpendicular to this equation right here, and it also has to go through the point -1, 2. Okay, so I'm just going to graph this line for now. Okay, this is in slope-intercept form, y equals mx plus b form. I see that my y-intercept, which is right here, is -3. So I can plot a point at -3. Okay, and my slope is 4. So that means my rise is 4, and remember 4 is the same thing as 4 over 1, so my run is going to be 1. So I can rise 4, run 1. I can rise 4 and run 1. I can rise 4 and run 1. Okay, and then the next one looks like it would be up about right here. Or I could go in the other direction. I could go down 4 and then to the left 1. I could go down 4 and then to the left 1. And then just to make sure this line is really straight, I'm going to switch to the line tool. I'm going to connect from there all the way through there, and that should pretty much go through all the points I plotted. If they were exact, it would be perfect, but I'm not exact. There we go. Okay, so that is the line for this equation right here. Remember, it would technically have arrows on it, so they would go on forever. So I'm just going to draw arrows on it. Okay, and so now we have to write the equation of a line that is perpendicular to it. And so this new equation, okay, I'm going to change my color to pink, I guess. All right, it's still going to have to be in y equals mx plus b form because that's probably the easiest. Okay, but one thing to know is that the slope of an equation that is perpendicular to another line, its slope is the opposite. Okay, so my perpendicular equation, I'm just going to go PE, not for physical education, but perpendicular equation is going to have be y equals, it's going to be opposite, which means opposite means like it's going to take the negative of the other slope, and it's going to be its reciprocal, which remember means you flip it. Okay, remember m is the same thing as m over 1, so it's going to be -1 over m. Okay, and then plus it's going to have a new y-intercept, so if we call that b1, we'll just call this one b2 to represent a new y-intercept. Okay, so if I look, my equation up there, okay, y equals 4